All right, so this one only has one step, okay? But like in terms of one calculation, that is. So we have a bird that flies 650 meters north. What did they just give me? Displacement, because I got north on the end of that, right? In the end, it's not going to make a difference here because it only goes north, but okay, we still have to write it down as a displacement. So 650 meters north. All right, and it does so at a velocity of 9 meters per second north. So obviously that's v with the arrow over top because they told us that. So velocity is 9.0 meters per second north. All right. How long is it flying for? What do they want us to find? Time. How long is time? Okay, so there's our givens. Okay, that would make this our best choice for a formula to use. And we need to manipulate for t. Okay, so what do I move first? Weirdly, the thing I move first is t, the thing I'm actually looking for. Because right now, t is on the bottom. And we can't solve for something if it's on the bottom because we'll be solving for 1 over that number, which is the inverse of it, not what we're looking for. Okay, so I'm going to multiply both sides by t. T comes over here, right? Now I want to get t by itself. I'm multiplying by v, so what do I do with v? Divide it over to the other side, right? Want to move something? Do the opposite. Okay, so t is going to equal d over v. And guys, honestly, like I'm putting the arrows over top of this. If you're showing your work on this question, as long as in your givens it had the arrow over top, you don't have to keep putting the arrow over top of the rest of it. Okay? All right, so we're going to have 650 meters north divided by 9.0 meters per second north. Okay, north's going to cancel. Meters are going to cancel. I'm going to be left with seconds. Okay, so 650 over 9. Sorry, I forgot to start my calculator. What does that come up to?
72.2 repeating.
Okay, so 72.2 meters, or sorry, not meters, seconds. Okay, 72.2 seconds. Okay, is that ringing a bell from yesterday? All right, we did ones way harder than that. Okay, that's much harder, but more involved. They had more steps. Okay, here's the thing about a more complex question like the ones we did yesterday. It's always the same steps. It's always this. Right? In some way, shape, or form, you are manipulating v equals d over t. Right? That's what they all end up coming down to. All right, I'm going to give you one that's like one of the complex ones we did yesterday. Okay, where direction matters and that kind of thing. Okay, so write this one down so you have it in your notes. Okay, it's good to have as many examples as possible. An elevator travels up 85 meters in 30 seconds. Then travels 60 meters down in 20 seconds. I would like the average speed and the average velocity over the entire trip. Okay, so break it up into part 1 and part 2. Okay, so we want to break this up into its 2 parts because it is asking us for the average over the entire trip. Okay, this is where we have to remember that these formulas actually mean average velocity is total displacement divided by total time, and that average speed is total distance divided by total time. Okay, so in part 1, okay, the elevator goes 85 meters up. All right, that's a displacement. 85 meters up. Okay, and it does that in 30 seconds. Okay, in part 2, it travels 60 meters down, another displacement. Okay, and it does that in 20 seconds. So this one's actually a little easier than the last one we did yesterday. 85 meters up, 60 down. What's my total displacement over the whole trip? 15 meters. Am I above where I started or below? Above, okay? All we're doing here, guys, is this, right? We went 85 meters up, and then we turned around and came 60 meters down, okay? That's 15 meters that's left. We're 15 meters above our initial position, so our total displacement is 15 meters up. All right, what's our total distance? I went 85 meters, and then I went 60 meters. How far did I go? 145 meters, right? Distance doesn't care whether I went up or down, just how far I went. So my total distance is just those two numbers added together, and it always will be. Okay, so 145 meters. That's it. Okay. What's my total time? 50 seconds. Okay.
I'm pretty sure 85 minus 60 is 25.
Absolutely it is. You should be pretty sure, because you're absolutely right. I'm going to blame that on lack of coffee. I'm not sufficiently caffeinated. That's my story, and I'm sticking to it. Okay. Total time, 50 seconds. Total time. Good idea. Not meters. See? It's caffeine. It's totally the lack of caffeine. Seconds. That might have something to do with lack of sleep, too. When you get old, it'll happen to you, too. Time knows where you live. Okay, so we've got total displacement, we got total distance, we got total time. We can do both of those calculations now. What's the average speed? Okay, average speed, total distance divided by total time. That is 145 meters. Pretty sure I did that one right? Okay. Divided by 50 seconds. I have no confidence in anything I'm doing. Okay, so 145. Oh, come on. Didn't even start the first time I pressed it. Okay, 145 divided by 50. All right, so the average speed of the elevator is 2.9 meters per second. Okay, and that's it. Don't have to put a direction on it. Speed is scalar. Okay, next thing, average velocity. Okay, average velocity is 25 meters up divided by 50 seconds. Pretty sure that's going to come up to 0.5 meters per second up. Okay. Would you get it wrong if you didn't put up on that? You absolutely would. A vector quantity needs a vector. What's the most common mistake people make after doing absolutely everything right on a question like that? Forgetting to put up on it. Okay? What I've seen some people do, and it's a good idea, is if they notice that they're solving for a vector, they'll like highlight that question in a certain color so that they remember they've got to check for a vector at the end. Okay, any questions on that? Because next Friday, we're going to have a quiz, and it's going to be on this kind of stuff and the graphing stuff that we're going to start. Okay? I would say a question like that would absolutely be the kind of thing I would ask on that quiz. Okay? Now, in this thing, did you have to do any really difficult math? Right? Had to subtract a couple numbers, had to add a couple numbers, although for me that proved actually quite difficult because I did it wrong a couple of times. Okay? But, I mean, if you have calculators, you know, and you actually use it, unlike me. Okay, it shouldn't be too tough, right? We're dividing a couple numbers, adding a couple numbers, okay? None of the math you're gonna do here, guys, is gonna be super rigorous, okay? It's just figuring out what math to do. All right, now yesterday, oh, no, I want you to try this one first. Okay, this is like the mother of all V equals D over T multiple part questions. Okay? And it's 3 parts. And it's about elephants. Not that that matters. Okay, give you guys a few minutes to work on that one. Do it just like the last one. Okay, and you also look at the rabbit example from yesterday. The method there can help as well. Okay, put those ones together and you should be able to get this one. So one of the other things that makes this question really involved is I put all sorts of units in it. Right? I give you meters per second, and then I give you hours, and then I give you kilometers. Okay? I'm making you do a lot of conversions here because that's something we have to do a lot of in physics. Okay? So let's start writing these givens down. Okay? We'll say in part 1, okay, we know that the elephants walk for 1.1 hours at a velocity of 3.0 meters per second. Okay, do I want my time in hours or seconds then? My velocity is in meters per second. My time should probably be in seconds. Needs to match, okay? All my units have to match when I'm gonna start doing math. I can't divide meters per second by hours. That's like dividing apples by oranges. I don't know what I get in that situation. The units have to be the same. So I'm gonna right away convert my 1.1 hours to seconds. How many seconds in an hour? Everybody's like knee-jerk here, 60! That's what everybody says when they first ask that question, except it's 60 minutes in an hour. In every one of those minutes, there are how many seconds? 60. 60 times 60? 3,600 seconds. Okay, so we're going to take 3,600 seconds, and we're going to multiply that by 1.1 hours. Okay, 3,960 seconds. Okay, and they told us that the velocity was 3.0 meters per second north. Okay, that's all we got for part 1. In part 2, they walk 7 kilometers south. Okay, so in part 2, the displacement is 7, should I have this in meters or kilometers? Meters. My velocity is in meters per second. I want everything to match my velocity. Otherwise, changing the units for velocity is called a compound conversion, and it's more work. It's easier to do the singles and make them match up with meters per second. Okay, so how many meters in 7 kilometers? 7,000. Okay, I need everybody to be able to answer that question automatic. Okay, metric conversions are crucial for physics. Okay, the metric system, did we talk about the metric system yesterday? I know I talked about it with my other 2 classes. Okay, so here's the beauty of the metric system, guys, and I know it's not your fault. You've never been forced to memorize it, even though you should have been, okay? You haven't. Now you have to, okay? Metric system, you've got this, okay? I think it's actually on your data sheet. Okay, did I put it on there? Yeah. Okay, every time you move up or down a level on here, okay, your number gets either 10 times bigger or 10 times smaller. Okay, so all you really have to do, okay, when you're trying to convert, like let's say 7.0 kilometers, okay, if I want to get that to meters, okay, well, kilometers is here. Okay, I'm going to go down to meters. That's 1, 2, 3 steps on the chart. Everybody with me there? Okay, so I'm going to take 7.0 and I'm going to move the decimal 1, 2, 3 times 7,000 meters. Okay, or you can go, all right, 3 moves, if it's 3 levels, it's 10 to the 3. That's 1,000, multiply it by 1,000. Okay, if you're going up, it would be 10 to the minus 3. So instead of 1,000, it would be 0.001 that you'd be multiplying by. Whichever way works for you, I don't care, but you've got to be able to do that. Okay, you've got to be able to make metric conversions because it's going to happen all the time. Okay, all right, 7,000 meters. Now, kilometers to meters is the most common one. Just memorize. K abbreviates for 1,000. Doesn't matter what it is. Kilometers, kilograms, kiloliters, kilobytes. That's the beauty of the metric system. Kilo always means 1,000. Okay, everybody with me there? That's why we changed to the metric system. Okay, in the imperial system, it's worse. You got to remember there's 12 inches in a foot, 3 feet in a yard, 5,280 feet in a mile, 8 ounces in a pound, or is it 16? I can never remember. See the problem? Like you got to remember all these other stupid numbers because nothing ever makes sense. It's always a different number. Okay? In the metric system, every move is a factor of 10. Every time you move up or down, it's either 10 times bigger or 10 times smaller. Okay? That makes it so easy to use. Right? And we use the same thing for mass, for distance, for volume, all of it. Okay? It all works the same way. Okay. Metric system rant over. Know the metric system. Practice it at home. Okay. All right. So we got 7,000 meters, and we have 1.5 hours. So I need to convert that to seconds. Okay. So there's 3,600 seconds in an hour. So 3,600 times 1.5 should be 5,400, right? Yeah. Okay. 5,400 seconds. Okay. Then, part 3. Okay. Then they walk 4.5 meters per second north. For another 2 hours. Okay. There are 3,600 seconds in 1 hour. There are 7,200 seconds in 2 hours. Okay. I just went 3,600 times 2. Okay. I just did it in my head. All right. What is the overall distance traveled and the average velocity of the elephants? Okay. If I'm going to get the total distance traveled, I need to know how far they go in part 1 and how far they go in part 3. Would you agree? Okay. So I should probably solve for those things first. All right, I'm going to give you some time to work on that now that the unit conversions are done, because I would imagine that was probably giving people a little bit of trouble, or they just didn't do it and started plugging numbers in, and now you have the real numbers. Okay, so I'll give you a little bit of time to work on the rest of it here. All right, so we need to find how far, or actually the displacement in part 1, because that's what we can find with this. It'll be equal to the distance because this single section is a straight line. Okay, so I've got to take V equals D over T and manipulate it for D, which just means I'm multiplying both sides by T. Okay, so the operation will be 3.0 meters per second times 3,960 seconds. The seconds are going to cancel, and I'll be left with meters. All right, so 3 times 3,960. All right, 11,880 meters north. Okay, for part 1. Okay, part 2, I don't have to calculate anything. I already have D and T, so I'm good there. Okay, in part 3, I've got to do the same calculation. I need the displacement in part 3. So I'm just going to do this V times T thing that I did in the first one, and that'll be 4.5 meters per second times 7,200 seconds. Again, the seconds are going to cancel, and I'll be left with meters. All right, so 4.5 times 7,200. All right, so in that part, they go 3,000 or 32,400 meters north. Okay, now I have the displacement for each part. And since each part is a straight line, I also have the distance for each part. This is one of those rare cases I was telling you about where distance and displacement can be equal. Okay? For each individual part, it's equal because they only did this. They walked in a straight line north. Okay? So that means their distance is 11,880 meters. I just don't put the north on it. Same for part 2. Okay? So instead of 7,000 meters south, which is what I should have written there, okay, the distance is just 7,000 meters. Same is true for part 1. Okay, the displacement's 11,880 meters north. The distance is 11,880 meters. Okay, and then same for the last one. Okay, the distance is 32,400 meters without, okay, the direction on it. Everybody okay with that? Okay, I mean, really what we're saying is in each part, this is effectively what happened. Here's my initial position. I go 1, 2, 3, 4, 5 meters east. That's my displacement. How far did I go? 5 meters. Okay. Because I walked a straight line and didn't turn, my distance and my displacement are equal in that situation. Okay, so the first thing it wanted to know was, what's the total distance? Okay, what do I do with this number, that's supposed to be an M, okay, and this number to get the total distance? Just add them up. Yeah, okay, that's how far the elephants will have walked. Okay, so the 32,400 plus the 11,880 plus 7,000. All right, there's the total distance traveled by the elephants, 51,280 meters. You may think elephants are big and slow, but if they're walking all day, they can go a long way. How far is 51,280 meters in kilometers? 51.28 kilometers, yeah. Okay, that's how quick we got to be able to make those conversions. Okay, I just know, oh, that's 1,000. I just moved the decimal 3 places and I got my answer. Okay, everybody with me there? You'll get used to it, trust me. The more you do it, the faster you'll get at it. You just have to spend some time doing it. Okay, so let's do the second part of this. What's the average velocity of the elephants? Okay, so average velocity is the total displacement divided by the total time. Now, displacement's vector, so now direction matters. Part 1 and 3, the elephants walk north. In part 2, they walk south. So I've got to take that into account. All right, so I'm going to say, here's part 1. Okay, that's 11,880 meters to the north. I'll say that way is north. Okay, all right, and then in part 2, they walk 7,000 meters south. Okay, so they backtracked quite a bit. Okay, and then in part 3, they go 32,400 meters. Okay, so when I put these together, basically I need to add up the ones that are east and then subtract the south, or add them all up and make south negative. Okay, that's actually what we do in physics a lot. Okay, is we just assign this direction is positive, this direction is negative, and then we just add everything. Okay, we just put a negative in for some of them. Right, so total displacement here, okay, is going to be, well, actually I'm just going to copy that operation right there. And I'm just going to make the 7,000 negative, or actually I'll subtract it. Okay, so they actually only end up 37,280 meters from where they started in a northerly direction. Okay, everybody follow what I did there? All right, so my total displacement, 37,280 meters north. And I need the total time. Well, I got the time for all three parts, 3,960, 5,400, and 7,200. So what do I do with all those times? I want to get the total, I add them all together. Okay, so 3,960 plus 5,400 plus 7,200. All right, 16,560. Okay, so I'm dividing meters north by seconds. So my units will be meters per second north, right? Okay, take my total displacement, divide it by my total time. Okay. On average, the velocity of the elephants was 2.25 meters per second north. Okay. Is that a pretty long question? It is. Did you have to do anything more complex than V equals D over T? No. I mean, sure, you probably don't like the metric conversions. Sorry, not sorry. You're gonna have to learn to do metric conversions, okay? But really, in the end, metric conversions are either multiplying or dividing, and that's it, okay? We're not doing any really complex math here, but figuring out what math to do, that's the tricky part, okay? All right, I'm gonna give you guys about a 4-minute break here, okay? And then we're gonna do a couple more like this, okay? Okay, on page 2 there, so when you flip over the cover, the next page, okay, the one that says Science 10, velocity, speed, displacement, distance, and time, okay? I want you to do the following questions. So just circle them. 4, 5, 7, 9, 11, and 12. I doubt we'll get all of those done today, and that's okay. All right, that's what I want you working on today. It's just like what we've been doing. Some are easier, some are more like the elephant question or the rabbit question, okay? But you're capable of them. This is how we learn this stuff and get better at it, is to practice. All right, if you have any questions, just pop on up and ask, or catch me while I'm circulating, okay? And I will definitely help you with them, and we'll go through each and every one of those on the board. I'll give you a few minutes to get ahead of me, and then we'll do the first one, and so on and so on. So you can kind of have the correct answers there to use to prepare. All right. So for number 4, okay, we know that the bus travels 11 kilometers with an average velocity of 21 meters per second, okay, then travels 1 kilometer at a smaller velocity of 4.2 meters per second due to the presence of highway construction. What's the average velocity of the bus? Okay, now, what's wrong with this question? Nothing that will affect your math, but what's wrong with the question? Exactly. This should say speed. Everywhere it says velocity in this question, it should say speed. Okay? Because it doesn't give you a direction on any of them. Okay? So what we've got here in part 1 is that we have a distance of 11,000 meters. Why did I do that? Right, it said 11 kilometers, and my units for speed are in meters per second. Okay. Gotta make my units match. Can't do any math until all the units match. Okay. Then in part 2, okay, we go 1.0 kilometers, which is 1,000 meters. Okay, at 4.2 meters per second. Okay, what's the average speed of the bus over the entire trip. I don't know where I got north from when I did that, because it doesn't say north anywhere in the question, does it? Okay, this is just calculating a speed. So there's a few things wrong, okay, with this question. All right, totals. Total distance traveled, 11,000 plus 1,000 is 12,000 meters. Okay, now, I still need the total time. How do I get it? What do I need to do in both part 1 and 2? Ollie, what do I have to do?
For what?
In part 1 and 2, I don't have time.
You have to divide 11,000 by 21.
Right, okay, I've got to manipulate V equals D over T for T. So I got to move T over to this side, divide both sides by V. Okay, so T equals D over V. And as Ollie said, I've got to divide 11,000 meters by 21 meters per second. That'll leave me with seconds. All right, so in part 1, 11,000 meters divided by 21 meters per second. That during that part, it will travel 523.81 meters. All right, now here's something we haven't talked about yet. I will often round on the board, but every time I do a calculation, I use the entire number that was in my calculator, as should you. Okay, we don't want to round anything until the very end, just like what we did with the mole equation. We said don't round until the very end. That holds true, probably even more importantly, in physics. Okay, all right, and then in part 2, I have to do the same calculation, so I'm not going to bother to re-manipulate. I'm just going to copy it over. T equals D over V, 1,000 meters divided by 4.2 meters per second. Meters will cancel. Okay, and right there, that's why I had to do it, right? Kilometers divided by meters doesn't cancel, but meters divided by meters cancels. Okay, 1,000 divided by 4.2, 238.1 seconds. Okay, but again, I'm keeping all of my decimals in my calculator. All right, now I can get my total time. 238 plus 523. Okay, so I add those together. I've got a total time of 761.9 seconds. Okay, now I can do the calculation they wanted me to do. Speed is total distance divided by total time. 12,000 meters divided by 761.9 seconds. Okay, so now I can round, okay, 15.8 meters per second. Great. Yes. All right, any questions on 4? How many people are done 5? Okay, we'll give you a little bit more time on that. All right, so speed of sound in air at room temperature is 343 meters per second. Yesterday I told you the speed of sound was 330 meters per second, which is also true at 0 degrees Celsius. The actual temperature of the air actually increases the speed of sound. Okay, so we have speed of 343 meters per second. Okay, how much time in seconds will it take thunder to travel 1,609 meters? That's 1 mile. Okay, 1 mile is 1,609 meters. Okay, so that'll be our distance. All right, so I'm going to use V equals D over T, and I'm going to solve for T. So I'm going to move T over to this side by multiplying both sides by it, and then I'm going to divide both sides by V. That'll leave me with T equals D over V, 1,609 meters, okay, divided by 343. Okay. All right. So if we do this, then we will have 1,609, okay, divided by 343. Okay, so 4.69 seconds. Now, if you ever want to know how far away a lightning strike is, if you see it, count how many seconds it takes for the sound to get there. Okay, multiply that by 343, and you've got how far away the lightning was. Incidentally, if you see the lightning and hear the thunder at the same time, it's really darn close. Don't follow it. It's a little scarier then. Okay? All right, tomorrow we're going to continue working on those questions. Okay, and then on Monday we're going to go over graphing. All right. Also tomorrow we'll go over your plant transport labs. All right, good work today, guys.